Alrighty, welcome back to Linear Algebra. We're going to start off today with Anki. Yes, indeed. Yes, indeed. Anki. Alright, and then we're going to jump back into doing some more. We'll grade what we did yesterday, then we'll do 2 more practice problems from 1.5, then we'll continue doing, or at least 1.4 flashcards, logging them. What are the commutative law for addition, the associative law for addition, the associative law for multiplication, and the left and right distributed laws for matrices? Commutative law is A plus B equals B plus A. Associative law for addition is within parentheses A plus B, and then that plus C equals A plus in parentheses B plus C. The associative law of multiplication states that A times B within parentheses times C is the same or equal to A times within parentheses B times C. The left distributive law for matrices, okay. So A parenthesis B plus C equals AB plus BC. And then if you've got parenthesis B plus C and then A on the right side, it's going to distribute back. So it's going to be BA plus CA. All right, it's good to me. Good. What is is it true that the inverse of A equals 1 divided by A if A does not equal 0? No. Matrix division is not defined. It's not a defined operation. If R is the reduced row echelon form of a square matrix and R has no 0 rows, then what must be true of matrix R? It's equal to I, the identity matrix. Is it possible to get a 0 matrix by multiplying 2 non-zero matrices? Yes. What is the trivial solution for a homogeneous linear system in unknowns? The trivial solution is x1 equals 0, x2 equals 0, ... xn equals 0. If A, B, and C are matrices for which A, B equals AC and A does not equal 0, does it follow that B equals C? No, not necessarily. The cancellation law does not hold in general. Okay. Actually, let's undo that. Let's say that was bad because I didn't say cancellation law. I want cancellation law to be stated. What is an invertible matrix and what is another name for such a matrix? Well, an invertible matrix is a matrix in which another matrix exists that when multiplied together, A times B, it equals the same as multiplying the other times the first, B times A, and both equal I. Square matrix, okay, well, I missed it. A square matrix in which another matrix of the same size commutes, and their product is I. Another name is non-singular. Well, that's not great. What did I forget? I forgot to say non-singular first of all. I forgot to say it was a square matrix. It is not true in general that the matrix product AB is the same as the matrix product BA. State 3 ways in which equality can fail to hold. A and B and A can be different sizes. A and B can be defined, and B and A can be undefined, or vice versa. A and B and A can have the same sizes but different entries. All right, good. How many different inverses can an invertible matrix have? 1. If A, B, and C are matrices in which A, B equals AC and A does not equal 0, does it follow that B equals Z? No, not necessarily. In general, the cancellation law does not hold for matrix multiplication. An invertible matrix is a square matrix in which another matrix, in which it commutes with another matrix, and that matrix that it commutes with, their product is equal to I. Another name for invertible matrix is non-singular matrix. All right, there we go. Now I'm going to grade the work I did yesterday, and then I'll be back after that. Got both of them from yesterday right. We're going to go ahead and do 2 more, and then I'm going to do more flashcards, and then I'll be back after that to recall what I did. Completed 2 problems. 5 was asking to find what elementary row operation occurred, or this elementary row or this identity matrix underwent in order to get this, and then show just that when you have E times A, then the result is going to be if you perform the same elementary row operation on A itself, which we did. Good. This one was just basically given two matrices, A and B, show or find E. And so we just found that you swap row 3 and 1 from A to get B. And so here's the elementary matrix that represents that. All right, and we got 4 more flashcards logged. So we have 12 out of the 18 logged for 1.4. So another solid day. Talk to you tomorrow. See you.